Okay, so these notes are going to be on factoring polynomials. In order to factor, remember that we need to create multiplication. So at the end of the day, you have to ask yourself, do I have two or more things that are being multiplied? The steps to factoring are always going to be the same no matter what. The very first step is, what do they have in common? What do they all have in common? Maybe I should add that. All of them must have it in common. Regardless of whether they have something in common or not, you still have to ask yourself, is it a binomial? And for binomials, we're used to checking if it's a difference of two squares, but we're going to be focusing more on, is it a difference or a sum of cubes? And we're going to learn how to factor that. If it's not a binomial and it's not special, then we go on to ask, is it a trinomial? A trinomial, remember, we do earmuffs. We have to say what multiplies to AC, what adds to B, but then we have to divide both sides by A. At the end, you simplify and bottoms up. Or you could just do it. Remember the just do it method. Then another thing we're going to focus on today is, what if they have four or more terms? Then we factor by grouping. So this is pretty much, we start with a GCF, but they're not always going to have something in common. So we'll see some examples of that. Alright, special formulas that you need to know is that a difference of two squares, if you see a squared minus b squared, it's a plus b, a minus b. Now we're going to go over sum and difference of cubes. So the way that I do this, it's a trick. I call it SOAP. That's an O, SOAP. So this is going to end up being a binomial times a trinomial. And same, opposite, always positive. So SOAP stands for the signs. So same means I'm going to keep the same sign. Opposite means opposite sign, and then always positive. From here we have to ask ourselves, who is being cubed? In this case, it's A and B. Once you put A and B, the rest I do a smiley face. A times A is A squared, A times B is AB, and B times B is B squared. Before, we used to do a smile, and we used to say like, oh, it's got to be a negative, but that's why I always do SOAP first. Always do your signs first, and then do the dumping. Another thing that we used to do before is, when it was A minus B squared, we used to double it. So it used to be 2AB. Notice that here we're not doubling it because it's a power of 1. Alright, again we can do it again using A cubed plus B cubed. Cubes work with a sum or a difference. And again we're going to use SOAP. So same sign would make it a positive, opposite sign would make it a negative, and always positive. Who is being cubed? A and B. So then you do A squared, A times B is AB, and B times B is B squared. And you're done. Something you should note is that this should not be factorable. Unless you forgot a GCF to begin with, but at this point you shouldn't be able to factor this anymore. If they had a 2 in there, then you would, but the formula doesn't have a 2, therefore it's not. Okay? And this is where the 2 comes in. In a perfect square trinomial, if I have a squared plus 2ab plus b squared, then this becomes a plus b squared. So if it had a 2, then it would be factorable. Or if it had a squared minus 2ab plus b squared, then it would be factorable as a minus b squared. But again, these, in our formula, we don't double up. Okay? Alright, first example. It says to factor, and we're going to factor completely. So the very first step is, what do they have in common? Well, I'm looking at the fact that this is a binomial. The very first thing I start with is numbers. What number can go into both of them? And I know that you think 4, but you have to think bigger. But if you go with 4, you can still fix it. So let's say 8. And then I think of what letter goes in there. Well, x to the n, because he's the poor guy and he can give it up. Each of them can also give up y to the n. So now, this is what they have in common. What they have in common, I only write it once. So this is what they have in common. And then because I have 2 apartments or 2 terms, then I'm going to have 2 leftovers. So 24 divided by 8 is 3. And then when I have x to the 2n divided by x to the n, we know that if they're being multiplied and they have the same base, I can add the exponents. So when they're being divided and they have the same base, I get to subtract the exponents. We don't just cancel off the n's. We're literally subtracting exponents. So that's how we get x to the n. And then y to the n's cancel, minus 5. Again, it's going to be your common times your leftovers. Your goal should be that if you distribute it out, 3 times 8 is 24, x to the n times x to the n, we add the exponents, x to the 2n, and then y to the n. And if I distribute this to the 5, you get negative 40 x to the n, y to the n. At this point, you should still ask yourself if you can keep going. Inside, they have nothing in common. It's a binomial, but they're not perfect squares, so we stop. The next one. Step 1 is, what do they have in common? Nothing. Is it a binomial? No. It's a trinomial. And then once you say it's a trinomial, you can start with the x method, or you could just ask yourself right away, is this a special trinomial? And the answer is yes, because it starts and it ends with a perfect square. So that means this would be x, this would be a squared. The square root of 49 is 7, and because it's a minus, that's a minus. It doesn't take long to check. X times x is x squared. This is negative 7 times 2 is negative 14x, and then 7 times 7 is positive 49. You can also write it out if you want to. You can write it as x minus 7 times x minus 7. But really, once you spot that it's a trinomial and it's a perfect square trinomial, you can just do that. Remember, the answer is the factored form. All right, backside. First step is, what do they have in common? The answer is nothing. Second step, is it a binomial? Yes. Is it special? Yeah. These are perfect squares. So with a perfect square, I know that it's going to be 2 parentheses. Hi, come on in. The square root of 81 is 9, so 9 times 9 is 81. The square root of 4a squared is positive 2a, and then negative 2a. Okay, so again, because I need to get a minus, I need a plus and a minus. And then I can still double check. 9 times 9 is 81. 2a times negative 2a is negative 4a squared. If I do the little lip, I get 18 minus 18 is 0 a's. And I'm done. But if you look at it, it's kind of ugly. I like letters to be first. So just letting you know that it can be written as 2a plus 9 and negative 2a plus 9. Like if I write the letters first. But you should also note that it can also be written as 2a plus 9. And if I really wanted this to be 2a minus 9, I would have to take out a negative. Because then a negative times 2a is negative 2a, and a negative times negative 9 is positive 9. So just know that they can all be good. Alright, so you should know that they're all pretty good. They're all good answers. Number 4, what do they have in common? Nothing. Is it a binomial? No. Is it a trinomial? Yes. And it's a beautiful, perfect trinomial. So because these are perfect squares, I can write them as a single, because it needs to multiply to a positive, so square root of x to the 4th would be x squared. The square root of 49 is 7, and because he's a positive, he's a positive. And I can even double check my work. X squared squared is x to the 4th. If I multiply these two, I get 7x squared. Doubled is 14x squared. 7 times 7 is 49. The next one, what do they have in common? 5a. And that leaves us with a cubed minus 1. But anytime I have a degree inside of parentheses, I need to start over. And I need to ask myself, okay, starting again inside the parentheses, what do these two have in common? Nothing. Is it a binomial? Yes. Is it a special binomial? Yes. It's a cubes. But when we do cubes, you need to make sure that you take an extra step and write it as something to the power of 3 minus something to the power of 3. In this case, a is being cubed and 1 is being cubed. A to the power of 3 is a cubed. 1 to the power of 3 is 1. Let's not forget our GCF. And because this is a cubes, we're going to soap it. So it'll be a binomial and then a trinomial. Same sign would make it negative, opposite is positive, and always positive is positive. So same sign, opposite, always positive. From here, all we do is we dump the things that are being cubed, not the cubes themselves. So like the cube root of them. So that's a and that's 1. If you do a times a, I get a squared, a times 1 is a, and 1 times 1 is 1. And again, he's not factorable anymore. He has a degree 1 and they have nothing in common. Even though he's degree 2, it's not factorable because it doesn't have a 2. So we're done. Don't forget that GCF. Number 6. What do they have in common? They have a 2u in common, which is u cubed plus 27. And then you start over inside the parentheses. Well, do they have something in common? No. Is it a binomial? Yes. Is it a special binomial? Of course. We can write it as something cubed plus something cubed. In this case, this is u, and the thing that is being cubed here, it is a 3. So let's not forget about 2u, who they had in common to begin with. And then because this is a sum of cubes, I'm going to SOAP it. Same sign, opposite sign, always positive. From here, we dump whoever is being cubed. Not 27, but the cube root of it. So that's u3. U times u is u squared. U times 3 is 3u. 3 times 3 is 9. And then you're done. My suggestion is to always check first times first and last times last. You don't have time to multiply it all out. But you can at least check u times u squared is u cubed. positive 3 times positive 9 is positive 27. And that works. Okay? Alright. Number 7. What do they all have in common? Nothing. Is it a binomial? No. Is it a trinomial? No. It's 4 terms. So we're going to do grouping. In Algebra 1, we used to group the first two and then the last two. So we're going to do that. But it doesn't always work. So beware. You can also group things out of order, but I always start in order 2 and 2. So at this point, these two, even though they all don't have anything in common, the first two have a y in common. So that's x plus 3. The next two have a positive 2 in common. Notice that I put plus 2. I didn't put 2. It's plus 2. But because I have a plus 2, that means I haven't quite factored. I did not create multiplication. But instead of having an entire thing of 4 terms, we have a binomial, 2 terms. We have this plus this. So now that I have a binomial, I have to start over. What do they have in common? Oh, they both have an x plus 3. So we write x plus 3. And then I'm going to multiply what they have in common times whatever is left over. If he gave up his x plus 3, you would have y left. And if he gave up x plus 3, you would have 2 left. And if you multiply y times that, I get this part. Plus 2 times that, I would get this part. So it seems legit. And it seems like I've created multiplication. So I'm done. Number 8. First group these two, then group these two. These two have a b in common, which is a plus 1. These two, if it starts with a negative, take out a negative. And I'm going to take out a negative 1. If they have nothing in common, you would take out a positive 1. Like you would still take out something, a 1, a positive 1. But in this case, they have a negative 1 in common, so that's a plus 1. Now I have a binomial. What do these two binomials have in common? A plus 1. And if he gives up a plus 1, there's a b. And if he gives up a plus 1, there's a minus 1 left. And I've created multiplication. So with 4 or more terms, when you have to do factor by grouping, you're not done after the first step. You have to do like an extra step. Okay? So there's always at least going to be 2 lines. Number 9. I can look at x to the 6 minus y to the 6 and get freaked out, or I could just go through the motions. So what do they have in common? Nothing. Is it a binomial? Yes. Is it a special binomial? Technically, yeah. You can write it as, hang on 1 minute. Okay, sorry. So again, it is a binomial, and we can write it as either something to the power of 3. We can write it as like a difference of cubes. Or we can write it as a difference of squares. So if I write it as a difference of cubes, it would be x squared, because 2 times 3 is 6, and y squared, because 2 times 3 is 6. Or you can also write it as a difference of squares. Well, who would be squared to get x to the 6? That would be x to the 3 and y to the 3. 3 times 2 is 6, 3 times 2 is 6. And then we have to consider, would you rather do cubes, and you have to focus on the structure, either something to the power of 3 minus something to the power of 3, or would you rather do something to the power of 2 minus something to the power of 2? You can do whichever one, but I prefer difference of squares because they're easier. So it's like, what if I told you like something to the power of 2 minus something to the power of 2? Well, you would say that it's triangle minus box times triangle plus box, right? Because it's a difference of squares. So we're going to do the same thing. Because it's a square, I'm going to set up my 2 parentheses. And in order to create subtraction, I need a plus and I need a minus. And then I need to dump whatever is inside. So x cubed goes here and here. Y cubed goes here and here. And you can check, is x cubed times x cubed x to the 6? Yeah. and it's negative y cubed times positive y cubed, or the other way around, does this give me negative y to the 6? And the answer is yes. So then at this point you think you're done, except you have to check inside the parentheses again. Can you factor this again? And the answer is yes, it is a sum of cubes. So we're going to go ahead and SOAP this one. Binomial times a trinomial. So this one right here can be factored even more. So same, opposite, always positive. Which means who is being cubed? X, and then y is being cubed. For the rest, you do a smiley face. That's x squared, this is xy, and this is y squared. And then we can do it again for this guy over here. He can still be split up into a binomial times a trinomial. Same sign would be negative, opposite sign is positive, and always positive. And then at this point we could say, okay, who's being cubed? X and y. X times x is x squared, x times y is xy, y times y is y squared. And then you would look again inside the parentheses. Can this be factored? Well, no, they have nothing in common, and it's a power of 1, so we're done. Can this be factored? Well, he's a perfect square and he's a perfect square, but he's missing a 2, so no. And then this can't be factored, this can be factored, so finally we are done. Okay. The last one is also 4 terms. They all have nothing in common. It is not a binomial, it is not a trinomial, it is 4 terms. So I'm going to try to factor by grouping. But before I start with 2 and 2, I realize, or hopefully you realize, that this is special. That is a difference of perfect squares. Not a difference of perfect squares, sorry. A perfect square trinomial. It starts with a perfect square, it ends in a perfect square. So if you do the 2 and the 2, you're going to realize that they have nothing in common. Maybe I should try that. I'll show you. So don't write this down. But imagine I had x squared minus 6x plus 9 minus z squared. If you do these and you say, okay, these have an x in common, these have nothing in common, you realize that you didn't factor and these have nothing in common. So you'd have to start over. So then maybe you're like, okay, let's start over. X squared minus 6x plus 9 minus z squared. And then you're like, okay, these have an x in common. And then this, I can write it as 3 plus z, 3 minus z. But then again, there's nothing you can do. They have nothing in common. It's not a beautiful binomial. So you're kind of like left in the dust. So instead, let's go ahead and group 3 things and then 1. Well, if I want to factor this, this becomes x minus 3 squared. Because x times x is x squared, negative 3 times 2 is negative 6, and 3 times 3 is 9. Minus z squared. Notice I still haven't factored because there's a minus in there. Now, the next step is using this binomial. They have nothing in common, but it is a perfect square trinomial. Not a trinomial. It is a difference of 2 squares. You have something squared minus something squared. So I know that in order to get a minus, I need a sign to be positive and a sign to be negative. First times first needs to multiply to the first thing, which is x minus 3 squared, which means this has to be x minus 3, x minus 3. And this would have to be z
Sebastian
and z.
Ospina, please come to room 4. Sebastian Ospina, please come to room 4.
Alright, so again, once we do this, they have nothing in common, but at least it's a perfect square. It's a difference of 2 perfect squares. So you would just split it up as x minus 3 plus z minus z. And you can stop. Or we can also write it as x plus z minus 3, x minus z minus 3. If you want the letters to be together. It doesn't matter. And that's it.